Alright kids, today we're going to talk about our first topic in Mr. T. Gray's videos. These are going to be your lecture notes for this year. This first topic is longitude and latitude. We're going to find locations on planet Earth. So on your paper you are to follow along and fill out your notes as we go. So this is an example of a typical graph. It's made up of points that are connected by a line. So I'm going to do a little kind of math to explain to you longitude and latitude. This should all be reviewed today. You should not be thinking of anything new, okay? So it's made up of points, which are right here. These are points that are connected by a line. These points are otherwise known as coordinates. Each point has two values. It has an x value that runs along the x-axis. X is running east to west, x is running left to right, x is flat. The way I think about it is x is the opposite, it crosses, and these lines never cross, okay? So a y value runs along the vertical axis. So we have x runs left to right, x is flat, y goes up and down. So each point that I look at is expressed as an x value and a y value, with the x value always written first. For example, we have 7, 5. 7 because we went 1, 2, 3, 4, 5, 6, 7 over, and then 1, 2, 3, 4, 5 up. 7, 5, x, y. Next, I have 4, 7. I went 1, 2, 3, 4 over, and I went 1, 2, 3, 4, 5, 6, 7 up. X, y, longitude or latitude, then longitude. So graphs can be divided into quadrants with the x and y values being positive or negative depending on the quadrant they're located in. Let me explain this to you. So, if I'm starting here in the middle, my x is going backwards. So I have a negative x. My y is still going up, so I have a positive y. Now I have a positive x because I'm going forwards, and a positive y because I'm going up. I have a negative x, or I'm sorry, a negative x this way and a negative y. Now I have a positive x and a negative y. Now, if this doesn't make any sense to you, if you're like, what is this dude talking about? Well, first of all, you need to pay more attention in your math class. Second of all, don't worry about it. I'm going to explain it another way. Let's apply these same ideas to longitude and latitude. All right, on a map, horizontal lines, and this is what you should be writing down, are lines of latitude, and vertical lines are lines of longitude. If you don't know what horizontal and vertical means, think of horizontal like the horizon. The horizon goes left to right, east and west. Okay, and vertical, I think the V, both of them go up and down, or both sides of a V go up and down, so I think of that as vertical. Vertical's up and down, horizontal is left to right. Okay, so the x-axis here is the equator. This is just like on my graph. I have my x-axis, there's the equator. I have my y-axis, that is the prime meridian. Prime meridian. So any location that is north of the equator is north latitude. Any location south of the equator is south latitude. Any location west of the prime meridian is west longitude. Any location east of the y-axis or the prime meridian is east longitude. So we divide the Earth, just like we showed on our graph, into quadrants. Northeast, or positive, positive. Okay. So what is latitude? Latitude is the distance from the equator along the y-axis. So in other words, here's my x-axis. Anything that runs parallel to this line, any line that runs east and west as well, is measured from the x-axis but goes along the y-axis. It is always expressed in degrees. The North Pole, way up at the top, is at 90 degrees. The South Pole is at 90 degrees south. So we have 0 degrees is the equator. Then we have 90 degrees south all the way at the bottom and 90 degrees north all the way at the top. So what's the maximum possible latitude on Earth? 90. You can never be at 90, or you can never be at over 90 degrees north or 90 degrees south, because then it starts over on the other side. There is no greater latitude on Earth. So what is longitude? Longitude is the distance from the prime meridian along the x-axis. So what does that mean? That means that here is my x-axis, okay? My longitude goes up and down. It is measured from the prime meridian, east and west of the prime meridian. Now, latitude and longitude are different in that longitude can be measured up and down going all the way around the world in a circle, but latitude only goes halfway up and halfway down. So latitude is 90 and longitude is 180. Now, the toughest thing for kids is that latitude runs left and right, east and west, but is measured north and south of the equator. Longitude runs north and south, but is measured east and west of the prime meridian. We will be going through this a lot more in class over the next 2 to 3 days, so if you don't get it right now, you will. All right. So what I want you to do right now is you can pause the video on this screen. I'm going to first walk you through letter A. Then you're going to do B, C, and D by yourself. Each box on this map is worth 15 degrees. With that in mind, how can we identify the specific locations? Let's do A together. I always start here on 0, 0. 0 degrees latitude, 0 degrees longitude. I'm going to go back 2 boxes. So if I go back, this is 15, this is 30. Okay? But I'm not looking for longitude first. I'm looking for latitude first. So I'm going to go 15, 30, 45, 60. So my first coordinate for latitude, distance from the equator, is 60 degrees north of the equator. So on your paper you write 60 degree symbol N, or north. Now I go back to my 0, 0. 15, 30. So my longitude is 30 degrees, and I went back or west of the prime meridian. So my latitude and longitude, 60 degrees north, 30 degrees west. I want you to pause the video and do B, C, and D by yourself now. Okay, here's some things to remember. Latitude is written first and always is north or south of the equator. Longitude is written next and must always be east and west of the prime meridian. As with anything else, you'll learn and get better with this through practice, so